So, continuing on with our discussion on atomic and nuclear physics topic, let's now take a look at the concept of the laser. The laser is a light source that produces a beam of highly coherent and very nearly monochromatic light as a result of cooperative emission from many atoms. The name laser itself is an acronym for light amplification by stimulated emission of radiation. By stimulated emission of radiation or stimulated emission of photons. So that's at the very heart of what a laser is. Say you have an atom in its ground level or ground state and it absorbs a photon, so E1. The atom is at energy state E1, ground state. It absorbs a photon of energy HF, bringing it to an excited level, energy level En. Sometime later, the atom on its own returns to its ground level, emitting a photon with the same frequency. So emitting a photon of energy EF. So from excited energy state En to energy level E1, En minus E1, the difference in the energy is just equal to the photon energy HF. This process is called spontaneous emission. On the other hand, stimulated emission, you have a photon of energy HF, frequency F, and that photon encounters an atom that's already in its excited energy state En, and if that photon stimulates the atom to emit a photon, the atom goes back to its ground state, or it goes back to a lower energy level, say the ground state energy of the atom. The atom emits a photon of the same frequency. So final result, you have two photons of the same frequency. One photon before the emission, two photons after the emission. You have stimulated emission. Since two photons are produced, or uh, in the result, you have two photons. So one photon initially, then two photons, thus the name light amplification. The original photon HF induces the atom to emit a photon. The atom goes back to a lower energy level, so En minus E1, resulting in two photons with the same frequency, is equal to 2HF. Stimulated emission, light amplification. Thus the name, light amplification by stimulated emission of radiation, laser. These two photons will have the same phase, thus they emerge together as a coherent beam. That's why a laser produces a beam consisting of a large number of coherent photons. And since they have the same frequency for the most part, the beam of light is monochromatic or just one color. Normally, a gas has more atoms in its ground state energy. For there to be stimulated emission, the atoms need to be in their excited energy state. Normally, though, more atoms are in the ground state energy, If you compare the atoms in the ground state energy and the atoms in the excited energy state, the ratio of the number of atoms in these two states is given by nx over ng is equal to E minus to the negative of Ex minus Eg divided by Kt. So exponential to the negative Ex minus Eg divided by Kt. K is the Boltzmann constant, equal to 1.38 times 10 to the negative 23 joules per coulomb. T is temperature in Kelvin. Nx is number of atoms in the excited state, and Ng is the number of atoms in the ground state. For stimulated emission to happen, there needs to be more atoms in the excited state. We need to have more atoms in the excited state than the atoms in the lower energy state. This is referred to as population inversion. So to produce a laser, you need to cause population inversion first in the atoms before we can produce stimulated emission. One way to do this is by using a mixture of gases. We excite one of the atoms of one gas, which will cause the atoms of the other gases to become excited as well. And then by introducing photons of the right frequency, we can induce the excited atoms to emit photons. We can induce stimulated emission with the excited atoms. One popular laser is the helium neon laser. So let's take a look at how the helium neon laser introduces population inversion into the system. So you have helium and neon atoms. So a helium neon mixture. The helium atoms are excited by two electrodes. Note, not electrons but electrodes. So you have a cathode and an anode. Not two electrons but two electrodes. The helium atoms are excited by the two electrodes. The excited helium atoms will collide with the neon atoms that are still in their ground state, thus resulting in excited neon atoms. Thus, we have population inversion in neon. And by introducing photons of the right frequency, the excited neon atoms may be stimulated to emit photons. So you have stimulated emission of the neon atoms, which are then sent back and forth between two mirrors. The helium atoms are again excited, which collide with the neon atoms, exciting them. And then the neon atoms are stimulated to emit photons. So you get more and more photons bouncing back and forth between two mirrors. One of the mirrors is only partially reflective, meaning some of the photons are able to pass through the mirror, and that's the beam of the laser that we see. A beam of photon emerges as an external beam which can be quite intense, has very parallel rays, is highly monochromatic, and is spatially coherent. Thus, you have a helium neon laser. So that's it for now. In the next video, we'll take a look at the concept of the radioactive decay. So thank you for watching.